Welcome to Summarize Science, where we break down complex research for everyone. Have you ever wondered how scientists measure the impact of a new law when there is no perfect control group to compare it to? Researchers often use a technique called the synthetic control method to create a digital version of a state or country. This digital version acts as a twin to show what might have happened if the law was never passed. However, this paper reveals that 3 popular wisdoms about this method are actually misconceptions. The first misconception is that the specific math settings you choose in your software do not really change the outcome. By running thousands of simulations, the authors found that small choices, like which category is left out of a list, can wildly swing the results. This means 2 researchers using the same data could come to different conclusions just by using different software defaults. The second myth is that you do not need extra details like age, race, or income if your digital twin matches the real unit's history. Some experts thought these extra covariates were unnecessary, but the simulations showed they are actually vital. Without this background information, the model can easily get confused by random noise in the data. This is especially dangerous when researchers only have a few years of data to look at before a policy change happens. The third big mistake is believing that a perfect match in the past means a perfect prediction for the future. You might see a graph where the digital twin and the real state overlap perfectly before a law is passed. But the study found that these perfect matches are often the most biased and inaccurate when predicting what happens next. It is a classic case of being too good to be true, where the computer overfits to random historical bumps. To test this, the researchers looked at the real-world example of Alaska's permanent fund dividend. They used this data to build a massive simulation to see where the math typically breaks down. They compared several different versions of the method, including some newer ones called OgSynth and GSynth. One major takeaway is that newer, more flexible models generally perform better than the older, standard versions. Specifically, the residualized version of OgSynth was often the most reliable across different scenarios. The paper advises scientists to stop relying on simple regression weights and to be more transparent about their choices. Now, let's recap the most important points for anyone using these models. First, software defaults matter more than we thought, so researchers need to justify their implementation choices. Second, always include background data like demographics to keep the model grounded in reality. Third, do not be fooled by a beautiful historical fit. It does not guarantee the results are unbiased. Looking ahead, this research suggests we need better ways to test our digital twins before trusting them. It calls for more cautious implementation and a healthy dose of skepticism when interpreting results. In the future, this could lead to more accurate reporting on whether social programs actually help people. It reminds us that even the most popular tools in science need to be double-checked and refined. Thanks for watching Summarize Science, and stay curious about the data behind the headlines.